Welcome back, everyone, to another deep dive. And today, well, it sounds pretty complex, this topic, but it's actually changing how we think about AI.
hmm
It's called many-shot in-context learning. And it's basically like teaching computers by just showing them a ton of examples,
Mm.
kind of like how we learn from each other.
Yeah.
And get this,
Mm.
the research that we're diving into suggests this could be even more powerful than how we've been training AI, like traditionally.
Yeah, it's definitely a fascinating shift.
Yeah.
You're right. It's like teaching a new skill,
Right.
Like you show them how to do it a bunch of times and then they pick it up eventually.
Yeah.
But here, what's remarkable is that these AI models are able to absorb information and generalize from like hundreds or even thousands of examples.
Okay. I'm already intrigued, but before we get ahead of ourselves, I have a question.
hmm
How is this many-shot approach different from like the few-shot learning that we've been hearing about?
Yeah.
Is it just like a matter of scale, or is there something more fundamental going on here?
That's a really good question, and it gets to the heart of it. Okay, so you see, traditional few-shot learning involved presenting the AI with a handful of examples, like
Wow.
maybe 5 or 10,
Okay.
hoping it would just figure it out. But with many-shot in-context learning, it's about feeding the model a massive set of examples, sometimes up to 1 million tokens.
Whoa.
Think of it like going from a short little tutorial to like a full-on immersive training program.
So it's like the AI is getting a crash course in whatever we're trying to teach it.
Exactly.
But what is enabling this? Like, is it just that our AI models have gotten bigger and smarter, or is there a technological, breakthrough behind this?
Well, both are really at play here.
Okay.
Advancements in AI model architecture, like we've seen with transformer networks, has certainly paved the way. But I think the real game changer is these models' ability to handle these incredibly long context windows, meaning they can process and remember vast amounts of information.
Okay.
Take Google's Gemini 1.5 Pro, for example. This can handle a context window of up to 1 million tokens, which is just
Whoa.
mind-boggling.
That's like reading an entire library in one go.
Yeah.
But how does this massive influx of information actually translate into, learning? What's
Well,
happening inside the AI's brain when it's, bombarded with all these examples?
Well, that's the fascinating thing. We are still trying to unravel the inner workings of these large language models.
Right.
But you can think of it as the AI is building this intricate web of connections between all these examples it's given.
Okay.
And the more examples it sees, the more refined and nuanced this web becomes, allowing it to make increasingly accurate predictions and generalizations.
So it's like it's building a mental map of the concept or the task that we're trying to teach it. And the more data points it gets, the more detailed and accurate that map becomes.
Exactly.
But does this work across different types of tasks, or are we limited to certain areas where this many-shot approach just kind of shines?
That's where the research gets really interesting. It turns out many-shot in-context learning is surprisingly versatile.
Oh.
We're seeing remarkable performance gains across a bunch of different tasks, from things like machine translation and text summarization to more complex problem-solving domains like planning and reasoning.
Okay, give me some examples.
Mhm.
How is this many-shot approach actually playing out in these different areas?
Okay, so let's start with machine translation, a field that's been revolutionized by AI in recent years. Research shows many-shot in-context learning achieving state-of-the-art performance on translating English into languages with very limited data, like Bemba and Kurdish.
Bemba and Kurdish, those aren't exactly everyday languages that you'd find in your typical translation app.
Yeah.
So the AI is able to translate into these less common languages simply by being shown enough examples. That's like a huge leap forward.
It is.
Wow.
What's even more impressive is that it outperformed specialized translation systems that were specifically designed for those languages.
Wait, so you're telling me that a general purpose AI model trained on a massive data set of text and code
Mhm.
can outperform models that were meticulously crafted for a specific translation task?
That's right.
That's incredible.
It challenges our assumptions about how AI learns and specializes, right?
Yeah.
It's not just limited to machine translation.
Okay.
The research also found that many-shot in-context learning nearly matched the performance of specialized models in text summarization.
Okay.
Think about being able to condense lengthy reports or articles into concise summaries in a fraction of the time.
Right. That's a time saver I could definitely get behind.
Yeah.
But let's move beyond these language-based tasks. What about areas that require more complex reasoning or problem solving? Can many-shot learning handle those as well?
That's where it gets even more interesting. The researchers actually tested it on a task called planning in the logistics domain,
Okay.
which involves optimizing the movement of packages and resources.
So we're talking about AI that can figure out the most efficient way to deliver packages or manage warehouse inventory or even optimize traffic flow.
Exactly. And this is a domain where traditional LLMs have really struggled because it requires not just understanding language, but also reasoning about spatial relationships, constraints, and goals.
Right.
And what they found was many shot in context learning led to significant improvements in the AI's ability to generate effective plans in this complex domain.
So this opens up possibilities for AI systems that can help us tackle like real-world logistical challenges
Exactly.
in ways that we never thought possible.
Hmm.
This is all incredibly promising. But I have to ask, what about the limitations? Surely there must be some drawbacks to this many-shot approach. For example, doesn't it require a massive amount of like human-generated examples to train these AI models?
You've hit on a key point. One of the main challenges with many-shot learning is the need for extensive data sets of examples. Creating these data sets can be time-consuming and expensive, especially for specialized tasks.
Right. And it seems like it could be a bottleneck for developing AI solutions in niche areas where there isn't a wealth of data available.
Yeah.
So what are researchers doing to address this limitation?
Well, they're exploring some really innovative approaches.
Oh,
Two of the most promising are reinforced in-context learning and unsupervised in-context learning.
right.
These techniques aim to reduce the reliance on human-generated examples and allow the AI to learn more autonomously.
Okay, those sound intriguing. Can you like break those down for me? What's the secret sauce behind these techniques?
Okay, so imagine instead of feeding the AI human-written examples, we let it generate its own examples and then learn from those. That's
Mm.
essentially the idea behind reinforced in-context learning.
So it's like the AI is playing a game against itself, trying to like constantly improve its score.
Yeah, that's a great analogy. It's constantly experimenting and learning from its own successes and failures.
Wow.
Now, unsupervised in-context learning takes this concept even further. In some cases, the AI can learn purely from a set of problems without any explicit solutions provided.
Wait, no solutions at all. That's like giving someone a math textbook, but like ripping out all the answers.
Right.
How can the AI possibly learn anything if it doesn't know like what it's aiming for?
It sounds counterintuitive,
Yeah.
but it's a testament to the incredible pattern recognition abilities of these large language models.
Okay.
In certain scenarios, the AI can glean enough information from the structure of the problems themselves to figure out the underlying rules and patterns. It's like solving a puzzle
Right.
by recognizing the shapes and how they fit together, even without seeing the finished picture.
Okay. That's mind-blowing. We've gone from AI needing step-by-step instructions to practically teaching itself.
Right.
But how does this change the dynamics of how AI learns? What's the big takeaway here?
One of the most important findings is that many-shot in-context learning has the potential to overcome biases that are inherent in the data used to pre-train these AI models.
Okay.
These models are trained on these massive data sets of text and code, and inevitably, these data sets reflect the biases and perspectives that exist in the real world.
Right. I've heard about how these biases can creep into AI systems and lead to like unfair discriminatory outcomes.
Right.
So how does many-shot learning help address that?
Well, imagine you're teaching an AI to analyze sentiment.
Okay.
Whether a piece of text is positive, negative, or neutral. Traditionally, you would train it on a data set of labeled examples where humans have already categorized the sentiment. But what if the labels themselves are biased?
So for example, if the data set was created by people who tend to associate certain words or phrases with negative sentiment, even if they're not actually negative.
Exactly.
Okay.
The AI would inherit that bias and perpetuate it in its analysis.
Right.
But with many-shot learning, something really fascinating happens. Even if you intentionally flip the labels, giving the AI incorrect information, it can still learn the task accurately if you provide it with enough examples.
Wait, so you're saying that the AI can figure out the correct sentiment, even if we're feeding it bad data? How is that possible?
That's the power of many-shot learning.
Wow.
With enough examples, the AI starts to recognize the underlying patterns and relationships in the data, regardless of the labels. It's like seeing through the noise to get to the heart of the matter.
That's incredible. So it's almost like the AI is developing its own like internal compass for judging sentiment, one that's less susceptible to the biases that might be present in the training data.
That's the hope.
Yeah.
It's still early days, but this research suggests that many-shot learning could be this powerful tool for creating AI systems that are more fair, unbiased, and aligned with human values.
This is truly groundbreaking stuff. We've talked about how many-shot learning can achieve state-of-the-art performance in translation and summarization, how it can tackle complex planning tasks, and how it might even help us overcome bias in AI systems. But before we dive into even more surprising findings of this research, let's take a quick pause to let all this sink in.
Welcome back. Before the break, we were discussing the remarkable ability of many-shot in-context learning to potentially mitigate bias in AI systems.
Right, and we were just starting to delve into some of the other surprising findings of this research.
Yeah.
You mentioned that many-shot learning could even challenge the need for fine-tuning. Can you elaborate on that? I'm curious to understand how this new approach stacks up against the gold standard.
Absolutely. So traditionally, to get the best performance out of an AI model for a specific task, we would fine-tune it.
Right.
So that means taking a pre-trained model and further training it on a smaller, specialized data set that's tailored to that particular task.
Oh.
Think of it like taking a general-purpose athlete and putting them through a rigorous training regimen to excel in a specific sport.
So fine-tuning is like giving the AI specialized coaching to become a master of a certain skill.
Exactly.
But you're saying that many-shot learning might be able to achieve comparable results without this extra step. That seems almost too good to be true.
It might sound counterintuitive.
Yeah.
But the research suggests that in certain cases, many-shot learning can indeed achieve performance that rivals or even surpasses fine-tuning.
Wow.
This is particularly true in areas like low-resource machine translation, where we might not have enough data to effectively fine-tune a model.
So for those less common languages like Bemba and Kurdish that we talked about earlier, many-shot learning could be a game changer.
Exactly.
You could potentially skip the costly and time-consuming step of fine-tuning and still get excellent translation results.
That's right. That's the exciting possibility that this research is pointing towards.
Yeah.
It could significantly lower the barrier to entry for developing AI solutions in specialized domains, especially those where data is scarce.
This is really shaking up our understanding of how AI learns and adapts. But I have a question.
Yeah.
We've been talking about how feeding the AI more examples generally leads to better performance.
Yeah.
But is there ever a point where too much information becomes a problem?
Yeah.
Could there be a sort of information overload effect
Yeah.
where adding more examples actually hinders the AI's learning?
That's a brilliant question.
Yeah.
And it's something the researchers explored in depth.
Okay.
You'd think that more examples would always be better,
Right.
but it turns out there are cases where too many examples can actually lead to a decrease in performance, particularly on tasks that involve complex problem solving.
That's surprising.
Yeah.
I would have thought that the more data the AI has to work with, the better it would be able to generalize and make accurate predictions.
Right.
Why would adding more examples sometimes backfire?
It's a bit of a mystery.
Yeah.
It highlights how much we still don't know about the inner workings of these large language models.
Right.
One hypothesis is that when the context window becomes too long, the AI might start to get bogged down in irrelevant information,
Okay.
making it harder to focus on the essential patterns.
It's like trying to find a needle in a haystack, but the haystack keeps getting bigger and bigger.
Exactly. The signal-to-noise ratio might start to decrease as the AI is bombarded with more and more information.
Right.
To try to understand this phenomenon, the researchers used a metric called negative log likelihood, NLL.
Okay, I'll admit, negative log likelihood sounds a bit intimidating.
Yeah,
Can you explain what that is in a way that a non-expert like me can grasp?
of course. Think of NLL as a measure of how surprised the AI is by a given outcome. The lower the NLL, the less surprised the AI is, which generally means it's more confident in its prediction. Traditionally, we've used NLL as a way to predict how well an AI model will perform as the context length increases.
So the assumption has been that as we feed the AI more examples and the NLO goes down, the model's performance should improve. But you're saying that this research challenges that assumption.
Precisely.
Okay.
What they found is that in certain problem-solving domains, NLL might not be a reliable indicator of actual task performance. They saw cases where the NLL continued to decrease as they added more examples, suggesting the AI was becoming more confident.
Right.
But the actual accuracy of its solutions plateaued or even declined.
So it's like the AI is getting more and more sure of itself, but it's not necessarily getting any smarter.
Right.
That's a bit unsettling.
It certainly raises some intriguing questions about how we measure and interpret AI performance. It seems that in the realm of many-shot learning, we might need to move beyond traditional metrics and develop a more nuanced understanding of what constitutes good performance.
This is all fascinating, but I'm curious. We've been focusing a lot on the Google Gemini model.
Right.
What about those other big players in the AI field, like OpenAI's GPT and Anthropic's Claude? Are they capable of handling these long context windows and leveraging this many-shot magic?
That's a great question, and the researchers didn't limit their investigation to just one model.
Okay.
They also tested GPT-4 Turbo and Claude 3 Opus, both of which have long context windows,
Right.
on that same low-resource machine translation task we discussed earlier,
Okay.
translating English into Bemba and Kurdish.
Drum roll, please. What were the results? Did these other models rise to the many-shot challenge?
Well, the results were a bit of a mixed bag.
Okay.
Both models showed improvements with many-shot learning on the English to Bemba translation,
Okay.
but they didn't see as much of a boost on the English to Kurdish translation.
So it seems like some models might be more naturally suited to this many-shot approach than others. Or perhaps certain language pairs are just inherently more challenging to translate with this method.
That's a plausible explanation.
Yeah.
It could be that the structure of certain languages or the relationships between languages makes them more or less amenable to many-shot learning.
Right.
But what's even more interesting is that the Gemini model, even though it initially started with lower performance than Claude on Bemba, actually learned much faster with more examples and eventually surpassed both Claude and GPT-4 in performance.
So it's like the tortoise and the hare.
Yeah.
The model that started out slower ultimately took the lead in the many-shot race. But this raises another question. Is there something special about these larger, more complex models that makes them particularly adept at many-shot learning? Or could smaller models benefit from this approach as well?
That's an excellent question, and the researchers were curious about that too.
Yeah.
They decided to test a smaller, long-context version of the Gemini model called Gemini 1.5 Flash.
Okay.
And what they found was quite surprising. Even this smaller model saw significant performance gains with many-shot learning.
Wow.
In fact, on some translation tasks, it even outperformed Claude 3 despite having initially worse few-shot performance.
Wow, that's unexpected.
Yeah.
So it's not just about the sheer size of the model, it's about the ability to effectively utilize those many examples, regardless of the model's scale.
Exactly.
This finding has some really exciting implications.
Yeah.
It suggests that many-shot in-context learning has the potential to democratize AI,
Right.
making it more accessible to those who might not have the resources to develop or train massive models. Smaller companies, research labs, and even individuals could potentially leverage this approach to create powerful AI solutions.
Yeah, exactly.
This is truly groundbreaking. We've seen the potential of many-shot learning to challenge fine-tuning, the surprising finding that more examples aren't always better, and now the possibility that this approach can work effectively even with smaller models.
Right.
But I'm sure there's even more to uncover. Before we dive into the final part of our deep dive, let's take a quick breather to recap some of the key takeaways so far.
Sounds like a plan. Let's give our listeners a moment to digest all this amazing information.
All right, brains rebooted. Before the break, we were talking about how even smaller AI models can benefit from this many-shot approach.
Yeah.
It's like leveling the playing field in the AI world.
Absolutely.
Yeah.
It really opens up the possibilities for more people to experiment with and utilize this technology. It's not just about who has the biggest model anymore. It's about who can leverage the power of many-shot learning most effectively.
And speaking of effectiveness, I've been thinking about this whole sweet spot when it comes to the number of examples.
Right.
Too few, and the AI doesn't have enough information.
Yeah.
Too many, and it might get overwhelmed.
Yeah.
How do we find that perfect balance? Is it just trial and error, or are there clues we could look for?
That's a question researchers are actively exploring. There's no one-size-fits-all answer yet, as the ideal number of examples can vary wildly depending on the complexity of the task and the specific AI model being used. But this research does offer some intriguing insights.
Okay.
For instance, they found that simply repeating the same set of examples multiple times didn't necessarily lead to significant improvements. It's not just about quantity, it's about the diversity and quality of the example.
So it's like a well-balanced diet for the AI.
Exactly.
Instead of feeding it the same thing over and over again, we need to provide it with a variety of nutritious examples that will help it grow and learn effectively. But how do we know which examples are the most nutritious, so to speak? Is there a way to evaluate their effectiveness?
That's a great question, and it touches upon a crucial aspect of many-shot learning, the importance of example selection and ordering. Think of it like this.
Okay.
If you're teaching someone a new skill, You wouldn't just show them random examples in any order.
Right.
You'd carefully select the most illustrative examples and present them in a logical sequence that builds understanding.
Right. You'd start with the basics and gradually introduce more complex concepts as the learner progresses.
Yeah.
So you're saying we need to apply those same principles to AI. We need to become like master teachers for these machines.
Precisely.
Right.
And the research suggests that even subtle changes in the order of examples can have a significant impact on the AI's performance.
Wow.
They found that an ordering that works well for one type of math problem might completely fail for another, even if the underlying concepts are similar.
That's a bit unsettling. It seems like we're walking a tightrope here, trying to find the perfect combination of examples and the optimal order to unlock the full potential of many-shot learning. Are there any tools or frameworks that can help us navigate this complex landscape?
That's where the field of prompt engineering comes in. Researchers are developing techniques and frameworks like DSPy,
Right.
which we touched upon earlier, that aim to optimize prompts for few-shot and potentially many-shot learning. These frameworks can analyze the data and suggest ways to structure and order examples to improve the AI's performance.
So instead of relying on intuition or trial and error, we could use these tools to guide our example selection and ordering.
Exactly.
That would be a huge step towards making many-shot learning more efficient and reliable.
It would introduce a level of rigor and automation to the process, helping us move beyond guesswork and towards a more systematic approach. But even with these advancements, we're still in the early stages of understanding how example selection and ordering impact many-shot learning. There's a lot more research to be done to develop robust and generalizable methods.
It sounds like we're just scratching the surface of this technology's potential. But let's shift gears for a moment and talk about the bigger picture. What are the real-world implications of this many-shot revolution? How could this technology change our lives in the years to come?
The implications are vast and far-reaching. If we can harness the power of many-shot in-context learning effectively, we could potentially revolutionize how we interact with AI and how AI interacts with the world around us.
Okay.
Imagine a world where AI systems can adapt quickly to new tasks and domains,
Right.
becoming truly versatile problem solvers.
It's like having a team of super intelligent assistants who can learn on the fly and help us tackle any challenge that comes our way.
Exactly.
We could see breakthroughs in areas like personalized education, where AI tutors can tailor their teaching methods to each student's unique learning style. Or imagine AI-powered scientists who can analyze vast amounts of data to accelerate drug discovery or develop new renewable energy sources.
Exactly. And it's not just about creating smarter AI. It's about creating AI that is more aligned with human values and goals.
Okay.
If we can use many-shot learning to mitigate bias, ensure fairness, and promote transparency, we can build AI systems that are more trustworthy and beneficial for society as a whole.
So it's not just about advancing technology for technology's sake. It's about using this technology to create a better, more equitable, and more sustainable future. That's a vision worth striving for.
Absolutely. This research is just the tip of the iceberg. There's so much more to uncover, so many more mysteries to solve. But one thing is clear. Many-shot in-context learning has the potential to reshape the landscape of AI and its impact on our lives in profound and transformative ways.
I don't know about you, but I'm feeling incredibly inspired. This deep dive has opened my eyes to a whole new world of possibilities, and I'm excited to see how this groundbreaking technology evolves in the coming years.
As am I. It's truly an exciting time to be working in this field, and I have a feeling we're just getting started. Who knows what incredible breakthroughs await us just around the corner.
And that wraps up another deep dive. We've journeyed into the fascinating world of many-shot in-context learning, exploring its astonishing capabilities and grappling with its intriguing challenges. But this is just the beginning of the conversation. We encourage you to continue exploring, questioning, and discovering the wonders of this rapidly evolving field.
Until next time, keep those brains engaged and those curiosity fires burning.